Okay, Tiffany, I think your question is going to be answered in this question. Okay, so let's look at the order. I got a 3, power of 2, power of 1, no x's. That's what you want it to be. Okay, so this one's ready to go. It's a little bit longer, but it's ready to go. Okay, so we divide. We divide x into x to the third. Or x times what is x to the third?
3. 2.
X times what gives me xxx? Tabo, he spoke for you. X to the second power. So then we multiply through. X to the second times x is x to the third. X to the second times positive 3 is a positive 3x squared. And at this point, you subtract. If you're good with what subtraction means, go for it. Subtraction, though, again, is the same thing as changing the signs and adding. So that's what I'm going to do. So minus, minus. And then the first term cancels. And then I add. Tiffany, is this what you were talking about?
Yeah.
Okay. So now I'm going to add negative 2 and negative 3. So I'm adding two negatives together, and that gives me negative 5. So when I change this to minus, negative 2 added to a negative 3 gives me a negative 5. X squared. Bring down your next term.
If we didn't change it to negative, what would it equal?
It's still the same. It comes up the same whether you subtract or change the signs and add. You'd have negative 2 minus 3 is a negative 5. You get the same thing. You have to get the same thing. And I repeat the process. X times what gives me negative 5x squared? X times what gives me negative 5x squared? Negative 5x. And I multiply through. So it's very repetitive, same process over and over. Negative 5x times x is negative 5x squared. They match, they should. Negative 5x times positive 3 is a negative 15x. And then we're going to subtract. So we're going to change our signs and add, which is the same thing as subtracting. And again, you don't have to. You can just go negative 22 minus a negative 15. Maybe you just want to use a calculator. First one cancels. Negative 22 plus 15 gives me negative 7x. Bring down the next term. And we repeat the process one more time. I don't think I get any bigger than this for you. I don't. Because these can go up to x to the 4th, 5th, 6th. X times what is negative 7x? Jordan?
Negative 7.
Negative 7. And I multiply. Negative 7 times x, negative 7x. Negative 7 times positive 3, negative 21. I'm going to change my signs and add. First ones cancel and should every time. And then 21 and 21 is 42. Again, my remainder is plus the remainder over your divisor of x plus 3. Okay, due to time constraints, I'm only going to do not the next one, but the following one. So I'm going to work through it. I don't want to rush through it, so I'll just do one of the two. Okay. X to the third. There are no x squareds. This is why you have to check this. This is important. When I go to set this up then, this is what it's going to look like. How many x squareds are there? 0. There are no x squareds there in math. That means there are 0 of them. So in order, I'm going to put a 0 x squared. And then leave everything else the same. Does it make sense where I placed the 0 x squared? Stay in order. X to the third, x to the second, the x term, the constant term. So I am missing the x squared, so I'm going to put a 0 x squared there.
Why do you need the 0 x squared?
You'll see when we start the process here. All right. 4 divided into 8x to the third, or 4x times what? Gives you 8x to the third. And that's 2x to the second. And I multiply through. 2x to the second times 4x is 8x to the third. 2x to the second times negative 2 is negative 4x to the second. There's where I'm going to answer Jordan's question. If I didn't have this 0x squared there, this x squared would have fallen under the 6x, and you can't add those or subtract those because one's with a power and one's with 1.
So if there's not a squared anywhere, you have to add one.
Or if the x was missing, you have a 0x. Whatever term's missing is where you put that 0 whatever. Okay? Okay, we're going to subtract here, which is the same as changing the signs and adding. So cancels, 0 and 4 is 4. Bring down the next term. Everything else is going to be the same here. That 0 thing was the only difference. 4x divided into 4x squared. Or what do I multiply 4x by to get 4x squared? Positive x. Very good. And I multiply x through. X times 4x. 4x squared. X times minus 2 minus 2x. And here I subtract, which is the same thing as changing the signs and adding. First ones cancel and should every time. 6 plus 2 is 8x. Bring down the next term. When we go to divide here, you'll notice 4 goes nicely into 8. If you've got a number here where that 8x is like 3 or 9 or 7 or 5 or 6, 4 doesn't go to that, then you know you did something wrong because it's got to be nicely done. There won't be any fractions involved in the division process. Okay? So 4x times what is 8x?
2.
Positive 2. 2 times 4x is 8x. 2 times minus 2 is minus 4. We will change our signs and add. First one's canceled. They should every time. And then negative 5 plus 4 is a remainder of negative 1. It's possible to not have a remainder. I should have said that probably from the beginning. All the ones we did had one, but it's possible that you don't get one. And then our remainder is written as it is negative 1 over our divisor x minus 2. 4x minus 2, sorry. All right. You got to try these to really know if you know what you're doing. Because, like I said, especially if you've never seen it before, it's a little tougher to remember. Even though you know how to long divide and you know how to, what the steps are or should be, it makes it different when it's polynomials.